In this tutorial, we're going to focus on the idea of creating crowds using ice, a combination of rigged characters, and some motor BVH files. We'll start by loading up a model that we're going to use as our terrain for our crowd. In the models folder, let's pull in the environment model. And I'm going to customize it a little bit so that it works a little better for our intended scene. I'm going to go in and make sure I turn the performance options backface culling on so I can actually see into this set. And I'm going to get rid of the river. I don't really need the river in this example. And I'm going to take the path and grassy areas and merge them into a single object and use the Gator-like built-in tools within the merge operator. So we have our merge properties attributes. We're going to merge in all the materials and UVs. You also need to make sure when you merge together these two objects that you tile the UVs for the grassy and pathway areas. So if I draw a render region now, you can't see inside. There we go. So our grass and everything works properly. I'm going to make sure I freeze the grassy area and pathway for my newly created polymesh and delete the originals. So again, we can just double check. Everything works, and this will rename to grass and path, and I'm going to drop it into my environment model. We'll use this same object as our emitter. So right through ice, we'll create a polygon mesh, or sorry, a point cloud empty. I'll jump right into the ice tree, Alt-9. And under the Create menu, create a simulated ice tree. So we want characters to animate over time, therefore we need the power of simulation. I'll look in my emitters folder and I'll emit my particles in place. Remember, it's just a modification of the existing emit from surface compound. The particle shape is fine. I'm going to have a total number of particles of 100 for now, and a size of, let's say, 1. I can also take the shape and turn it into something like a box, just so I get a sense of volume. I'll use the grass path object as my emitter, so I'll pull it in and output its value into the emitter input. And I need a simulate particles node, so I'll pull the simulate particles node in as well. So if I press play and I actually move to frame 2, I have some boxes that represent the positions of the particles that were grown in place. My next goal would be to restrict some of these particles. I actually want the character to be running across the field from left to right. So I want the Melkor characters, who are eventually going to form the crowd, filtered so that they can only start on this side of the mesh. So I'll use a weight map to create that effect by painting a weight map directly on the emitter. If I get a weight map property and rename it, I'll call this weight map the Melkor emitter weight map. I'll just say WM for weight map. And if I press W to paint, I'll middle click and drag to enlarge my brush. And I'll have the characters emit from a fairly small area. And I'm going to use that weight map and filter out the particles that have no weight in their location. If we look under modifiers, sorry, let me just take a look. It's not under modifiers, but again, if you ever forget where things are, it's under emission control. I'll filter by weight map. I'll pull the weight map into my graph and execute on emit. I want the particles to be culled out right at the second frame. So if I actually move to frame 2, I'm returning red, an error, because I'm actually not finding the weight map. And the filter by weight map looks for a default weight map by the name of weight map. So if you've renamed your weight map, you're going to have to go and search for it. Look in my grassy, my weight map cluster to the Melkor emit weight map, and I'm going to need to pull the weights off of that. So right away we get a restriction of particles. So even though we're still emitting a total number of particles, 100, most of them have been culled out because of the weight map. So if you need more characters, you're going to have to increase the rate to increase the density of characters in that area. So I'm going to go with a lower number for now. Just say 100. Keep it at the default. Alright, so the first part is solved. And the next thing we need to do is get the particles moving in the direction we desire. So to do that, we're going to set the particle's velocity, which is going to allow us to set a vector direction for the particles to move along. We want to do this on the ice tree, of course, not in the Emit compound. So I'll add another port to my ice tree and have a look at any node that deals with velocity, and under setters particles find set particle velocity. So we're using a directional vector to push our particles. I want the particles to move in positive x, as I mentioned, so I'll set a value of, say, 4, and I get the particles moving in the positive x direction. Okay, so not working too bad. I'm going to vary the terrain ever so slightly by using proportional modeling and a fairly wide paintbrush. We're just going to have the terrain rise slightly. And the one thing that you'll notice is that even though the particles are being pushed in the correct direction, they're actually not respecting the terrain. So we need to have the particles follow the terrain and move along their x vector direction. So there we have our next task ahead of us.